Suppose that we've got that function, f of x and g of x. We want to find the total area bounded by those two graphs, x equals 1 and x equals 6. It says begin by graphing both functions, find the x-coordinate where they intersect. So let's do that first off. How do we find the intersection? Well, what we're going to do is set them equal to each other, right? Because this is really y, and this is really y, right? So they're just set them equal to each other. So we'll say, okay, um, 3/5 x minus 2/15 equals the other function, 5 over x. Okay, so what are we going to do? Well, when you've got a bunch of fractions, you got to get rid of them. I'm going to multiply through by 15x, 15x, and 15x. How did I decide on 15x? Well, because 5, I'm looking at all the denominators, everything under a bar. So that 5, that 15, and that x. I got to have all those pieces put together. 15 already includes 5 because 5 goes into 15. So I just need the 15 and I need the x. So 15x, and that'll include the 5 already. You need the x because that is part of the denominator. So you want to cancel now. So 5 goes into 15 three times. What's left over is 3x and 3x, which is 9x squared minus 15 cancels 15. What's left over is 2 and x. Let me hold up there for a minute. Let's finish it. X is x, and 5 times 15. Use your calculator if you need to. Is that 50 and 25? 75. Did you see that? So again, I multiplied all the way through with an equation, an equal sign problem. You can always multiply both sides by the same thing. I did all the terms on the left and the right by 15x. 5 went into 15, right? Things on underneath bars and things on the top is really, if it helps you, 15x over 1, 15x over 1, 15x over 1 is really what I multiplied through by. And things on the bottom go into the top. 5 goes into 15 three times. And you might say, why didn't these x's cancel? Because this x is really over 1, isn't he? He's not a denominator x. He's not under a bar, right? See, he's right here in the front. He's over 1, really. Anything alone is really over 1. So these guys multiplied each other to become x squared. And 3 multiplied 3, right? Because 5 went into 15, leaving a 3, and then 3 times 3 is 9. Same thing here. The 15's canceled, the 2 and the x, leave 2x. The x is canceled, 5 and 15 makes 75. Okay, we get to there. We go, oh, yeah, we know what to now bring the 75 over. And so now we've got 9x squared minus 2x minus 75 is 0. Okay, so now we can do the quadratic formula, huh? So negative b plus or minus square root of b squared minus 4ac all over 2a. Here's my A, my B, my C. So I'm going to go straight to the Desmos, plug it in. So negative, so here, I'll write it right here first off, and then I'll go to Desmos. So it's negative B, which is negative 2, double negative, plus or minus square root of B squared. I'll also go 2 squared because that negative is going to be positive. B squared minus 4 times A, which is 9 times C, which is negative 75 all over 2a. Let's go to Desmos, negative 2, plus or minus. So to Desmos we go. Fraction. So it's going to be 2 plus the square root of 2 squared, right? Because this is just negative, negative. That's going to, these two are going to become positive 2. Plus or minus 2 squared minus 4, 9, negative 75. Minus 4, 9, minus 4 times 9 times negative 75 over 2 over 2 times 9. There we go. And the answer is 3. Now, the other option, we do the minus, is something crazy. So we skip that one. Why is that crazy? Well, that negative, so it's 3 and negative 2.77. Let me write those down. So we get the answers x equals 3 or negative 2.777, etc. Why are we going to use the 3? The answer is 3 here. Well, because remember, we're going between x equals 1 and x equals 6. So this one is not between 1 and 6. So we want the 1, right? It says, so that's where they're going to do. We're just looking between 1 and 6. Okay. Define x equals 3. So that's the first step. We got that. That's where they intersect. And now it told us that we need to graph. So we do need to graph these. So how do we do that? Well, you just first off realize this one's going to be a line. So I'm going to bring it down here. I'm going to go, okay, the first one is y equals 3/5 x. 3/5 x minus 2/15. This is 3/5 x. Y equals 3/5 x minus 2/15. Do that better. 3/5 x. And the other equation is y equals 5 over x. So for both those equations, we got to make little tables and then do a graph. Okay, so I'm going to make a little table. And we're leaving y alone because these are dx in both cases. So that means we get y. So or y, which y is already alone, so it's good to go. Gonna make our table. So I'm gonna make an x, y table here. And I'm gonna plug in x. Now what x is? Well, we're going, again, remember where you're going from 1 to 6. So let's just plug in things from 1 to 6. So 1, 2, 3, 4, 5, 6. We probably don't, it's just a straight line, right? This is just y to the first power, x to the first power, not multiplied or divided. So it's just going to be a straight line. So really, I could just plug in. So I'm going to go Desmos 3/5 x minus 2/15. 3/5 x minus 2/15. 3/5. I forget what it was. But it's 3. So it's right here. It's 3/5 x. I'm going to plug in 1 first off. So I'm going to put it right here. 3/5 times 1 minus 2/15. 3/5 times 1 minus 2/15. This times 1 minus 2/15. And I get that 0.466. I'll say it's 0.5, close enough. 0.5. Now I'm going to plug in 2. Let's go back and change that to 2. What do I get? 1.1. Now I'm going to plug in 3. Just plugging in, just looking for some nice numbers, hopefully. 3 minus 1.7. None of these are really nice. Was it minus 1.7? I'm going to plug in 4. Yep. No. Or it was positive 1.7. No, I'm getting lost. Positive 1.7. Okay, now plug in 4. Awesome. So now plug in 4. 4. 2.3. Plug in 5. So this is a little tedious for sure. Minus 2.9. Wait, was that mine? I keep looking quick. No, it's just 2.9. 2.9. 2.9. And then finally plug in 6. 6. 3.5. All right. Well, none of those are too nice. It's a straight line. Okay. And now the other one, I'm going to make an X, oops, come on. XY chart. And same thing, I'm going to plug in X value 0, 1, 2, 3, 4, 5, 6. Oh, I didn't need 0, did I? Let me back that up. I forgot. Just start at 1. So 1, 2, 3. Getting a little sloppy here. 4, 5, 6. Okay. Plug in 1. It's going to be Y. Y is going to equal 5 over 1. Well, that's easy. That's 5. Y equals 5 over 2. Half of 5. 2.5. 5 over 3. You can just go to Desmos. I'll do 5 over 3. 5 over 3. And it's 1.7. 3, 1.7. Now plug in 4. 5 over 4. 5 over 4. 1.25. Let's call it 1.3. 5 over 5 is 1. 5 over 6 The last one here, 5 over 6, 0.8. All right. Now, this one's not going to be a straight line. You might think, well, it's just x and y in the first part. Yeah, but that x is divided. It's on the denominator. It's going to make it have curvature to it. All right. Anyway, long story short, we're going to graph these guys. So we need to go from 1 to 6 on the x-axis, right? So 1 to 6 on the x-axis. So let me see, I'm going to go like 1, 2, 3, 4, 5, 6. 1 to 6 on the x-axis. And just put down some points here for the red one. Over 1 up. Oh, and we got to go up to 3.5, looks like, on the y. So I'm going to do some y values here. 3.5. So let's see, 1, 2, 1, 2, 3. Up here, very top would be 4. Okay. And okay, so where are we going? Go back to it. So here we go. 1 over 1 up 0.5. Over 1 up 0.5. There's a dot. Okay. Over 2 up 1.1. Over 2 up 1.1, just a little bit higher. This is a straight line, so I'm going to jump to the end. Over 6 up 3.5. Over 6 up 3.5. Right about there. Okay, so this is a straight line. It's going to go sort of like that, right? So there we go. And now the blue one, this is going to be a little more curved. Over 1 up 5. Start with that over 1. Oh, it goes up 5, so it's going to go up a little higher, huh? There's 5. Over 1 up 5. I didn't realize it went all the way up there. Okay, so right up there. Over 1 up 5. Over 2 up 2.5. 2 up 2.5 right there. Over 3 up 1.7. This one has a little more curvature to it, something like that. Over 4 up 1.3. That one kind of coming down a little bit. Over 5 up 1. And so it's kind of flattening down. I'm off a little bit, but good enough. All right, so it kind of comes down like that. That's generally what it does. Okay, and oh yeah, not only that, we also have the lines. One of them being x equals 1 and the other being x equals 6. So x equals 1 and x equals 6. So let me put those on the graph. So x equals 1 is this line right here. It goes up, 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 at x equals 1. So I'll write that in. X equals 1. And then x equals 6 is the line over here. Whoops, did I miss it? Yeah, whatever. I'm off a little bit there. So that's the line x equals 6. So we want the region captured by those functions. Actually, two regions. That's this section and it's this section. See how it's in two sections? And they intersect at 3 like we already found. That's not a very good graph, but good enough for our graph. So we're going to have two separate integrals. This is the first integral. It's going to go from 1 to 3, from 1 to 3. And each of these is going to have little rectangles in it. Here, I'll show one of the rectangles like that. Here's one of the rectangles. It's going to have dx as its width, and its height will be this top function, the top function in here. In that section, that's the blue one, which is 5 over x. And the bottom function, which is down here, which is the other one, which is this guy, 3/5 x minus 2/15. So the red line, all right, y is 3/5 x minus 2/15, right? So therefore, this is the height, top minus bottom. So we're going to take top minus bottom. That'll give you the height of that rectangle times dx, the width of that rectangle, right? That's the height times the width. That's how we find the area of a rectangle. That'll give you the first one. So let's finish that one off right there. So that'll be the integral from 1 to 3. What's the top function? Well, that function is the 5 over x minus the bottom function, which is the 3/5 x minus 2/15. And you can just put parentheses around that dx. Okay, plus, and then you have the second integral. Here's the second one. It's this area. And in that area, again, we're going to have, rectangles that we're going to add up, like this rectangle here. Dx is the width. The height will be top minus bottom here, but they reverse, don't they? So it's going to be, that'll be the integral from 3, starts right here. 3 goes from 3 to 6, doesn't it? And it's top minus bottom again, right? Because that'll be the height, dx. And so that'll be the integral from 3 to 6. What's the top function? Well, in that region, the top function will actually be the red one. And that's the 3/5 x minus 2/15 minus the bottom one. The bottom one will actually be the 5 over x in that region, dx. And there we go. So there's the two different integrals they wanted. And that's what they mean by this first integral from 1 to 3 with the 5 over x in the front, and the second integral from 3 to 6 with the 5 over x in the back. And so that's how we get those two answers, because that's going to give us all the region here and here captured between those two graphs and then the lines x equals 1, x equals 6. And so there we go.